function. So the characteristics are those terms that we just talked about. They want the axis of symmetry, blah, blah, blah. And they give us this formula to work with. They expect us to graph it. Now, you might remember back from grade 7 or 8 that you can always create a graph from an equation just by plugging in a bunch of x values and getting the y values and plotting them. So we can do that. And that's what they expect you to do. They want you to plug in a value for x and get out the value for y. So I'll show you just really quickly how I would do that. I would go y equals -2 times, let's say that I want to use x equals 1, just because the math is easy and I'm lazy. So I've got 1 squared, actually let's put that in black, minus 6 times 1 plus 20. So I go 2 times 1 squared, oh sorry, -2 times 1 squared. Well, 1 squared is just 1 times -2, that gets me -2. -6 times 1 is just -6, plus 20 would give me -8, positive 20, 12. So I would be doing this and putting these values into a table where I have my x value, my y value. And I would want to make sure that I've got enough points on the table in order to complete a fairly decent graph. So typically, with these graphs, we don't really want to go too crazy. I could start at -3, go to 3. So if my x was -3, I plug it into the equation. Y is going to be 20. My x is -2. Plug that into the equation, and I'm going to get 24. -1 also gives me 24. Interesting. 0 would give me 20. 1 would give me 12. And what I'm seeing is a pattern. So basically it's going up, it's going up, it's capped out, it's going down, and it's going down by the same kinds of things. So I could extend this to a 2, plug it into my equation, and I would get 0. And I could even bring it further this way to see what I end up getting. At -4 would give me a 12. -5 would give me the 0 again, and I just have my x and y over here. So all I'm doing to get these values is I'm simply plugging them into the equation. Remember to put brackets around them when you square them, because if this were a negative and I didn't do the brackets, I'd screw up my sign. So bracket, negative, number, close bracket, then square. Okay? Then I would go over here and just graph it. So I would say, okay, I've got -5 and 0 as a point. So -5 and 0 is a point. And 2 and 0 is also a point. So I know that that's where those are going to sit. And then 12 and 1. So, or sorry, 1 and 12. 1 and 12 there. And -4 and 12. So they're going to, it's a symmetrical kind of thing. So it's just going to continue with this relationship. 3 and 20. So this 20 should be right on my line. Right there. And 24 is going to be up here. So I'm just going to roughly draw this out now with the points that I've got. It's going to look like that. And it's going to cap out somewhere between these guys. Actually, it's going to cap out at exactly -1.5, because that's where these two, I've got -1 here and -2 here. So my axis of symmetry has to be right up the middle between those two, because they have even points on either side. So I can tell a few things by that. I know that the top point is going to be between 24 and 24. It's going to be when x equals -1.5. So I could put -1.5 into this equation and get my y value. Or I could use my graphing calculator for the whole thing. So if I want to use my graphing calculator, I just plug this into my y equals line, and I hit graph, and it's going to give me a graph that looks like that, and I can read the points off of that graph. So it's kind of up to you which way you do it. If you're going to do it this way, it's going to take you a long time. So it's really important to know how. So I would probably try a few, maybe try a couple of points and make sure that they coincide with the graph that you do, but I wouldn't choose to do this for every problem. I would probably make sure you understand it, practice it a little, and use your graphing calculator for the rest. So in order to use your graphing calculator for this, you would plug this in, hit graph, and then you're going to need a few little tools in order to read the individual points. Because what they want to know, I'm just going to get rid of this so I've got some space. What they want to know for the first one is the x-intercepts and the y-intercept. Now you know that the x-intercept is where it hits the x line, and the y-intercept is where it hits the y line. So at the x-intercept, y is 0. So I can look down here, and I can see that they're at 2 and -5. And those are my x values. It's not a coordinate point. So I'm not going to put that in brackets. X is 2, x is -5 when y is 0, and those are the 2 points. Now in your graphing calculator, you can go to, where is it now? Second function, and then trace. It says calc over top of it. It is this button right here. And what that does is it's going to call up some little dots where you can left bound, right bound, narrow it down, and actually get that value. And it's easy to get these values when they land straight on the dot. You're going to have graphs that don't, so it's important to be able to use your graphing calculator to do this. So you're going to hit second function, trace. Now, it helps to turn your calculator on. Something I always have issue with. I've put this in my calculator, -2 x squared minus 6x plus 20. I've graphed it. I've got a big, huge graph that actually goes off of my page. So then I would hit window, and knowing approximately where the points should be will help me to set my window. My x min and max can stay where they are, but my y max is not enough. So I have to bring my y max up so that it includes 24. So I'm actually going to go to, I don't know, let's try 26. I put my graph in, and all the points are on my graph. So I've adjusted my window a little bit. That just means I've adjusted what these points are. All right. Now I've hit my second function, trace, and it comes to a screen that looks like this. What I want for this one is my zeros. So I can page down to the 0, or I can hit the 2. And it gives me a little cursor that I can move back and forth. I can't move it up and down. I can only use these buttons to move it. So it says left bound here at the bottom. Left bound means going that way, and I want to be going that way up this line. So I'm going to bring it down below the line, and then I hit enter. Then it changes to right bound. So now I move it so that if it were right bound, it would be coming towards this point that I want. And then I hit the enter button again. Then it says guess. Sounds weird, but it's what they want. So now you can see that 0 right there is x equals -5 when y equals 0. So that's how we use the second function calc, which is the trace button, to get zeros. I can also, so second function calc again, hit my 0, I spin over to the other side, dun, 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 dun. Look at it go, so amazing. And now it's left bound going this way, so I'm going to hit it before the line, enter, below the line right bound, enter, guess, and it says x equals 2, y equals 0. So I've already got those two values. Now you know how to use the calculator to get them. If I want my y-intercept, I go second function calc, value, because in my values, they let me put in any x value that I want. So if I put in x equals 0 and enter, then that's going to tell me that my y value, when x is 0, which is the intercept, is 20. Fancy, huh? All right. So I write down when x is 0, y is 20. Now, you don't have to write down these ones. I'm just making those notes so that you remember what we're talking about. But when you do it, you can just write my x-intercepts are 2 and -5, my y-intercept is 20. Okay? The next thing they want you to know is the coordinates of the vertex. So they want this point right here. So the coordinates of the vertex. And again, I can use my calculator. I know approximately where they're going to be. But if I want to use my calculator to find it exactly, then I go back to second function trace, and I see that this graph is a maximum graph because it's negative and it goes up to a point and then descends. So you can see that number 4 on here is my maximum. So I hit maximum. Again, it says left bound, so I'm just going to take it up just to the left of center there, hit enter, and then bring it to the right of center, hit enter again, and then hit guess. So it tells me that it's 1.4999999 forever, which is basically what -1.5, which is what we knew because it was right between -1 and -2. It tells me that the y value is actually 24.5. So this is giving me the point that is the maximum value. So this is the coordinates of the vertex. So I write -1.5 and 24.5. That's a coordinate point because I want my x value and my y value for that coordinates of the vertex. Now, the next thing they want is the equation of the axis of symmetry. Which is a lot to write out, even if I'm using shorthand. But the equation of the axis of symmetry is simply x equals -1.5. We know it's right there. That's it. Sounds so difficult when you look at all that, but this is all they want. They want the domain of the function. The domain of the function, I stopped this because I was just using basic points, but obviously if I wanted to continue this graph, I could, and it would just go on forever in the x direction, because it's just going to keep spreading out, ever so slowly, but still spreading out. There's no limit to what x could be, so x is in the realm of all real numbers. And that's going to be your domain for basically everything in the quadratics, because that's the nature of the graph. The range, however, for what y can be will be limited by whether or not it has a maximum or minimum, because there's no points beyond here. The good thing is we've already figured out what here is. It's 24.5. So y is greater than or equal, no, y goes up to 24.5, caps out. That means y has to be less than or equal to 24.5 in this case. So basically, your coordinates of your vertex will give you lots of information. It tells you the axis of symmetry, because that's what your x value is equal to. And it tells you what your range limitation is going to be. So you just have to check to see whether it goes up and then back down, or down and then back up, whether it's a maximum or a minimum. If it's a maximum point, then y is less than or equal to it. If it were a minimum point, then y would be greater than or equal to it, because it would be going down to it and then back up. So it would be a low point that the graph doesn't go past.